Hi, welcome back to AT Math. Today, 10-6 theoretical probability. More on probability and odds, more Vegas talk I'm sure, should go pretty quick. When the outcomes in the sample space of an experiment have the same chance of occurring, the outcomes are said to be equally likely. In other words, notice here that even though you only have a 1 in 4 chance of getting a certain color, every option has an equal chance. All of them have 1 out of 4. Here, there's 1 out of 4, but notice how the blue is much larger than all other pieces. So even though you still have a 1 in 4 chance, this one chance is much larger than the other, so that is not equally likely. A theoretical probability of an event is the ratio of the number of ways the event can occur to the total number of equally likely outcomes. In other words, number of ways the event can occur over total number of equally likely outcomes. Let's take a look and see. An experiment in which all outcomes are equally likely is said to be fair. So in other words, if you were to pick a color here, that would be considered fair because you have a fair chance to get one as much as the other. Where here, if you picked blue, you have a better chance than any other color. That would be not fair. An experiment consists of rolling a number of die. So again, 6-sided die. What's the chance of rolling a 3? Well, if you roll the die, there you get one chance out of 6 to get a 3. In other words, there's one possible outcome that you can get that's a 3. That means if you roll a 3, it's a 3. Any other number is not a 3. So the probability of rolling a 3 is 1 out of 6 possible. And if you take 1 divided by 6, you have a 16 2/3 chance of rolling that. An experiment consists of rolling a die in a cube, find the theoretical probability of each outcome. Now, rolling a number greater than 3, well, how many numbers are greater on a dice than 3? Well, you have 4, 5, and 6. So you can roll a 4, you can roll a 5, you can roll a 6. That's 3 possible outcomes out of 6 possible things, so 3 over 6, or 1/2. So you have a 50% chance of rolling more than a 3 on a die. When you toss a coin, there are 2 possible outcomes, heads or tails. The table below showing the theoretical probabilities, an experiment resulting from tossing a coin 10 times. So in other words, the experimental probability, let's say you went ahead and flipped a coin 10 times. And let's say it landed on heads 3 times, and tails 7. Now, remember, the more you flip the coin, the more likely it'll become 50% because of probability. But here you're saying you hit the head 3 times, tails 7, but if you add them all up, you get 10 out of 10. So in other words, it was 10 flips total. The theoretical probability should have been that 1 out of every 2 should be heads or should be tails. The sum of the probability of heads and the probability of tails is 1 or 100%. This is because it is certain that one of the 2 are going to happen. It's either going to flip heads or flip tails. You're not going to flip it, it's going to land on its side. It's going to land one way or the other. So the techie part is P times event happening plus P times the event not happening equals 1. In other words, the probability that landed heads was 3 out of 10 plus 7 out of 10 is what actually did land. So you got 10 out of 10, or if you actually do the theoretical, 1/2 plus 1/2 is also 1. Either way, when you combine either what did happen or what should happen, you should get 100% for either situation. The complement of an event is all the outcomes in the sample space that are not included in the event. The sum of the probability of an event is a complement is 1 or 100% because the event will either happen or not happen. So P times event plus B times the complement equals 1. Take a look. The weather forecaster predicts 20% chance of snow. What is the probability that it will not snow? Well, if it's 20% that it will snow, the part that it won't is 100 minus 20, which is 80%. Therefore, you're saying, okay, the probability that it will not snow is 80%. Probability that it will is 20. When you add both together, it's 100% something will occur. Either it will snow or it won't snow. Odds are another way to express the likelihood of an event. The odds in favor of an event describe the likelihood the event will occur. The odds against an event describe the likelihood the event will not occur. And in Vegas, odds are very often listed. They'll even tell you what the odds of something are to those very few who actually look at the odds and make a decision based on it. Odds are usually written with a colon form A to B. It can also be written as A to B or A to B or A over B. Odds in favor, number of way it can happen versus number of way it can fail. Now here's the difference. The difference between odds and probability. Well, in odds, it will be can happen versus can fail to happen, where probability is can happen versus total. Small difference, but it's there. And odds against an event, probably it can fail versus the way it can happen. You'll understand once I give an example. Take a look here. Probability of choosing a red card from a standard deck of playing cards is 50% because half are red, half are black. What are the odds of choosing a red card? Well, alright. Out of the whole possibility of a deck, since it's 50% you'll land a red card. 50% you will not land a red card. So let's say there are 52 cards, 26 of which are going to be red. So there's 26 possible outcomes where it will work, and 26 where they will not work. In other words, where they'll be black. So it's 1 over 1 or 1 to 1. The difference is, if it was probability, it would be 26 out of all possible, which is 52. So you have a 50% probability you're going to land it, but if you're looking at odds, it's 1 to 1. It means the same thing, you're just comparing the two different things. Take a look here. The odds of choosing against a green marble from a bag are 5 to 3. What are the probability of choosing a green marble? Okay, so the against was 5 to 3. First of all, how many are there total? There's 8 total. Alright, and if 5 of them are not green, 3 are. So 3 are out of 8 total, so your probability is 3 to 8. 3/8 that you will land a green one. And if you were to write it as odds, you would say there are 3 greens and there are 5 that aren't. So your odds are 3 to 5, and that's the difference. Probability includes total. Odds are likely versus unlikely. A little practice, you'll get that. And that's basically it. We will do more in class tomorrow. Again, expect some probability, expect some experiments. We'll see how it goes. Thanks again. Bye.